Right, good morning, Dharuni. Last week lesson, right, we stopped the lesson in the experimental techniques. Determine the disruptive method and the non-disruptive method. Like that way, I explained two types of methods. Disruptive method, non-disruptive method, right? Here in this one, disruptive method, in that one, I told you we disturb to the system. After then, we determine the concentrations. Non-disruptive method, in that one, right? We do not disturb the system, allow to happen the reaction. Then when happening the reaction, it is difficult to determine the concentration because we cannot conduct a titration. Because of that one, instead of measuring the concentration with the time, instead of determining the concentration, right, what we do there, with the time, we measure a different physical parameter, a different physical, right, quantity. Right, condition of that one is, right, that physical property should be, right, proportional to the concentration, directly proportional to the concentration. So with that idea, right, today we want to learn some methods, right? Briefly, we have to take idea about that one because you should aware about, right, different methods, right? When they are introducing that one, right, those methods actually we apply those methods in, right, university level, but in those methods, right, what we do, you should have a very simple idea about that one because they can prepare MCQs, right? තේරුණාද? දැන් ගිය සතියේ ඊයේ තිබ්බනේ පේපර් එක නේද? කොහොමද පේපර් එක දැක්කද? අහන්න තියෙන හැම තැනම අහලා තියෙන. කරනවා සියලු දේ අහලා තියෙන. හොඳ පේපර් එකක්. හැබැයි ඔක්කොම තියරි අහලා තියෙන. right? ඔක්කොම තියරි අහලා තියෙන ඔක්කොම ගන්නලක් තියෙන. මොනවද අඩුපාඩු නැහැ. right. අපි පාඩමට එමු. right. Last we had this one, right? The physical quantity should be directly proportional to the concentration of the components. Right? Examples. First example. Number one, spectrophotometric method. Spectrophotometric method. Spectrophotometric. Metric mean measure. Photo mean light. Right? Spectrophotometric method. Right? In this method, what we do, right? As I told earlier, right? We should have very simple idea about this one. So don't try to take a lot of details from, right, other places. Don't try to do that one. Simply we have to aware the method. Right? Descriptions, long descriptions, no need here. Spectrophotometric method. If you want to apply this one, actually in here what we do, we measure the color. Simply the idea is color. Simply measure the color. Instead of measuring the color, they are actually color intensity, right? We measure that one as the absorbance. Absorbance measure there. Okay. Therefore, now here, if you want to apply this method, when consider the reaction, in the reaction, at least one of these components must be with a special color. Okay, if these are colorless, we cannot apply this method. Okay, in the reaction, if one of the component is with a color, right, what we do, we can measure the absorbance, say the color. Say for example, this one is a colored one. If this one is a colored one, with the time at the beginning, no C. C is not there. Product is not there at the beginning. So no color. But with the time, what happened? With the time when C forming, color intensity gradually increase. Say for example, it is blue colored one. At the beginning, it is colorless. So blue color gradually increase. With that, the intensity of the color, varne tivrata, right, gradually increase. So with that, what we can do? We can measure the absorbance. Selected wavelength we take there using, right, instrument, right, spectrophotometric. So for that one, we use the instrument. Using that one, we measure the absorbance. So color intensity increase mean absorbance increase. So instead of measuring the C concentration, with the time C concentration increase, instead of that one, we measure the absorbance. Then using that one, we can express idea about the rate of the reaction. Only that thing. Terunada, a condition is one of the component must be with a color. Okay, take down this spectrophotometric method under that one. To conduct this method, comma, at least one of the species, involved in the reaction, should be with a color, online that one. At least one of the species should be with a color. At least one of the species should be with a color. Next line. Then it is possible to monitor the absorbance. Monitor the absorbance as a function of time. Comma, because the absorbance is directly proportional. Absorbance is directly proportional to the concentration of particular species. Therefore, rate of the reaction can be monitored by measuring the absorbance with the time. Below that one, right, like this say also absorbance proportional concentration. Number 2, second method. Second method. Second method, write the topic. Measuring the change in total pressure. Measuring the change when a swimmer change in total pressure. Right? Again, another non-destructive method. Right there, what we do, instead of measuring the concentration of certain component, right, in the system we measure the whole pressure, total pressure. So where we can apply that one, right? Where we can apply that one. Now, if you consider a reaction taken place in gaseous phase, a reaction taken place in gaseous phase, like this way, right? This one gas, this one gas, this one gas. Now, when happening the reaction, say that one pass towards the ammonia. When happening the reaction, total pressure of this system change, because total pressure given by the addition of partial pressure of this one, partial pressure of this one, partial pressure of this one. Addition, Dalton's law. With that, give the total pressure. Okay. So if a gaseous reaction, if components are in the gas phase, right? When reaction happening, according to the stoichiometry, sometimes pressure decrease, sometimes pressure increase. Total pressure, in that total pressure, there will be an increase or a decrease. So instead of measuring concentrations, we measure the pressure with the time. Pressure with the time. Okay. With that, we can have idea about the rate of the reaction. All right. That is another method. Here you have to remember this thing, that is, we can apply this method. Now, earlier method possible if a component is with a color. Right? We can apply this total pressure measuring method. We can apply that one if the system is in gaseous phase. එහෙම දැනගත්තාම ඇති. කරුණාද? ලියා ගන්න. Measuring the total pressure. On that one, right? This method can be applied. This method can be applied for gas phase reactions. Can be applied for gas phase reactions. Gas phase reactions. In here, instead of measuring concentration, comma, it is possible to monitor the total pressure. It is possible to monitor the total pressure as a function of time. As a function of time. In the first sentence, gas phase reactions, underline that one. In the second reaction, total pressure as a function of time, underline that one. Total pressure as a function of time. Then put a comma and write, continue the sentence. Function of time, comma, because total pressure of a gas phase reaction, total pressure of a gas phase reaction taken place in a rigid container, is always given by taken place in a rigid container is always given by the sum sum addition by the sum of the partial pressures of all gaseous reactants and products. All gaseous reactants and products. All right. Third method. Electrical conductivity. Or within a bracket write conductance. Electrical conductivity within a bracket conductance. Two different definitions, right? Both possible to use. Electrical conductivity or the conductance. Method. Close bracket and write method. Right? Where we can apply this method. Right? Now, say for example, earlier one, nitrogen, ammonia. Here you can't apply the, right? Electrical conductivity. Because in this kind of reaction, no ions involved. Somewhere when taking place a reaction, if ions involved in that one, For example, say sodium hydroxide HCl reaction. They are also ions because sodium ions, right? OH minus ions, right? H plus ions, Cl minus ions, like that, ions. Selenitrate, sodium chloride, chloride formation, ions involved. So if a reaction, right, involving ions, putih kalpanaye mahaganna, right? මම පාඩම ටටක් ගාලා යනවා ඉදිරියට. මොකද ගොඩාක් උගන්නන්න තියෙනවා. කරුණාද? සියලු දේ කියලා දෙන්න ඕනේ. එහෙනම් අහගෙනම ඉන්න. Right, if ions involved in the reaction, then we can use the conductivity method. Conductivity possible to measure, if not conductance even, all right. Usually we measure the conductivity. When ion concentration is high, conductivity is high. When ion concentration is low, conductivity is low. Okay. Now, if I consider this kind of reaction, as example, I can give you, right? Ester, if you take a ester and if you hydrolyze that one, ester break into parts. How ester produce? Ester produced by a carboxylic acid. Carboxylic acid and an alcohol. If a carboxylic acid and alcohol, from the carboxylic acid this OH group and from the acid this hydrogen. Alcohol from that one hydrogen, carboxylic acid from that OH. This part remove. Later in organic chemistry you can learn it, right? Then RCOOR dash. Ester produce. R C double bond O OR dash, like that. I use the R dash, they are alkyl groups. Right? We can hydrolyze this one. Say use sodium hydroxide, for example, like that, OH minus, by supplying OH minus. Again, you can break it. Right? Earlier when you are learning the, right, functional groups with that one. Functional group is that different types of organic compounds. When you are learning that one, I told you. Ester mean a carboxylic acid derivative. Ester mean a carboxylic acid derivative. Therefore, if you break the ester, we can have the carboxylic acid. Then with the OH minus, using H plus even we can do it. So using OH minus, we can hydrolyze this one. Then with that RC double bond O OH carboxylic acid and the alcohol R dash OH, these two produce. But as you know, right, when you consider carboxylic acid in a basic medium, all these are in the same medium. Okay, therefore carboxylic acid in a basic medium, is that possible? No, that one neutralize and convert into salt and ion produce. Therefore here the product is O minus. O minus. If sodium hydroxide use O minus Na plus, like that way. Then මේ paper එක ඔය තමයි හොයලා තිබ්බේ. මං කිව්වේ ඔයගලන්ට. කරුණාද? O minus Na plus, like that. So this is the reaction. Okay. Now in this reaction, at the beginning OH minus, right? With the time what happened? OH minus consuming. With the time OH minus consuming. With that, using conductivity method, instead of measuring the OH minus concentration, right, we can measure what? Conductivity of the solution. Instead of measuring the concentration, we can measure the conductivity. Now, when you consider the reaction, right, conductivity of a solution, පුතේ වචනයක්වත් අහක දාන්න නෑ. සියල්ල අහන් ඉන්න, right? When you consider a solution, conductivity in electrochemistry, you can learn that one later. Mainly H plus and the OH minus, right, contribute for the conduction. Electricity conduction, for that one, right, highest contribution given by the H plus. Other සිට මතක තියෙන්න ඕන. Highest contribution given by the H plus. Compared to H plus, this one is considerably low, but second highest contribution given by the OH minus. Highest contribution H plus. OH minus contribution less than that one, but second highest. H plus and OH minus give the highest contribution in a solution. ඒකෙනුත් වැඩිම කවුද? H plus. තරුණාද? Then other ions, say sodium ions, chloride ions, sulfates, like that way. If we consider the conductivity of those, how much contribute for the conduction of electricity, right? Conductivity of the sodium ion, chloride ion, sulfate ion, like that way. They are low, comparatively low than this. Because of that one, now when you consider this reaction, say the, right, ester is here. Ester is here. Okay, then into that one we add the sodium hydroxide OH minus supply. Now OH minus and RC double O, like that way. Now because of the OH minus in this medium, at the beginning the conductivity of the solution is high. Okay, so at the, right, 0 time initially, what is the conductivity of the solution? We take that one. After 5 minutes, now for that one we can put the 2 electrodes to this one, right, conductometer. With the time, you just have to take the reading here. Okay, so with the time, what happens to the conductivity of this one? What happened actually? At the beginning, OH minus, more OH minus, they have conductivity high, right? Reaction happening with that, this one produce, this one produce. Actually, if you consider the ions, number of ions, when consuming one OH minus, here one RC double O minus, again ion, right? When producing, or when reacting one OH minus, one an ion produced here. There were number of ions, if we consider that one here and here, same. But as you learn, contribution of OH minus for the conductivity is high. Contribution given by the RC double O minus is considerably low. Large ion, right? Conductivities of these ions in electrochemistry, can learn it. Conductivities of these ions directly relate to the speeds of those ions. ඒගොල්ලෝ ගමන් කරන වේගය. තේරුණාද? If ions flow rapidly, conductivity of that one is high. Later you can learn that one in electrochemistry. Now when you consider H plus, that is why it gives the highest contribution. Now when you consider this kind of one, a large anion, CH3CO minus, like that ion. So conductivity given by that one is low. Therefore, now here high contribution, less contribution, therefore, when decreasing this one, in the whole solution, conductivity gradually decrease. Conductivity gradually decrease, mean with that, we can have an idea, right? We can have a measurement, that is, instead of concentration, OH minus concentration, we can measure conductivity. With the time, conductivity decrease. OH minus concentration decrease, like that the conductivity decrease. Okay, with that, can have idea about the rate of the reaction. So reactions involving ions, right? First one, spectrophotometric method. If certain component is with a color, can measure the absorbance. With that, you can do it. Okay. Second method, if gaseous components, instead of measuring the concentrations, we can think about the total pressure of the system, because addition of partial pressures give the total pressure. In this method, instead of measuring the concentration, we can measure the conductivity. For that one, the condition is, in this kind of reaction, there must be ions. If ions involved in that one, you can do it. Another example, if I consider, right? මේක වැඩිපුර ඔයගොල්ලන් කියන්නේ මම මේ දැන් ෆිසිකල් උගන්වද්දී පුතේ ඔයගොල්ලන්ට එක්සැම්පල්ස් ගොඩක කියලා දෙනවා. නෝට් එක ඔය ඔක්කොම ගන්න බෑ. මම මේ කියන කතන්දර ඔක්කොම ගන්න බෑනේ නෝට් එකට. ඒකයි මම හැම වෙලෙම කියන්නේ හොඳින් අහගෙන ඉන්න කියලා. තේරුණාද? හොඳින් අහගෙන ඉන්න කියලා කියන්නේ ඒකයි. අදම ගෙදර ගිහලා පාඩම් කරන්න ඕනේ. හෙට නෙමෙයි ඈ. Now later you can learn this kind of thing also. Conductivities. By measuring the conductivities, we can do the titrations. Titrations. Okay, a method, conductometric titrations, like that. Right? Make a note in there, right? Now, titration flask, into that one, we put the 2 electrodes. Now we want to identify the endpoint of this reaction. Say the reaction is sodium hydroxide, HCl reaction. Sodium hydroxide is here. Assume HCl add into this one. At the beginning, OH minus in the medium, sodium hydroxide OH minus, because of that one, conductivity of the solution is high. Okay, here what we do, not the rate, here we want to think about a titration. Where are the end point? Equivalence point, where that one arises. Want to have idea about that one. Matakain equivalence point? Sodium hydroxide, at the beginning we measure the right conductivity of this one, right? Here the volume, here the right conductivity with the volume. At the beginning 0, right? Conductivity is high. Then you add H plus to this one. When adding H plus, what happens? H plus with the OH minus neutralize. Okay, as told earlier, chloride also come to the solution. Chloride come to the solution, but OH removing. Removal of OH, right? Because of that one, decrease the conductivity. So from the HCl, you add 5 cubic centimeters. Measure the conductivity. After adding 5 cubic centimeters, conductivity is less than that one. Okay. You add another 5 cubic centimeters. Measure the conductivity. Like that, when you're adding the HCl, what happens? Conductivity decrease. So we have to use constant volumes, right? With that one, right? 5 cubic centimeters. After that one, what is the conductivity? 10. Right? Like that, we add the HCl volume. Somewhere like this, we reach to a low value. After then, say, Here the equivalence point is 25 cubic centimeters. අපි හිතමු 25 කියලා. 25 cubic centimeters. After addition of 25 cubic centimeters, sodium hydroxide fully neutralized. At that moment, the conductivity of this solution is minimum. එහෙම නේද? Sodium hydroxide HCl like that way, all OH minus with the H plus neutralize. Only sodium ions and chloride ions. Okay, only sodium ions and chloride ions because of that one, right? Because of that one, right? In here, the conductivity is minimum at the equivalence point. After that one, right? Say you add further HCl, තවත් පහක් එක් කරා. When add another 5, what happened? Now H plus come to the medium with that conductivity again start to increase. Again start to increase. Therefore, what happened? Say 5, 10, 15, 20, 25, 30, 35, 40 like that, we add the HCl. With the volumes, we measure the conductivities. Then we mark those like this way. After then what we do? We combine these like this way. Somewhere you can have a minimum. At once you can't decide the equivalence point. When you are drawing the plot like this, say the minimum mean, what is that? Minimum conductivity that is with the equivalence point. Then here the volume, with that you can read the volume, that is the equivalence point. Karunadu. Conductivity at the beginning high, conductivity gradually decrease. So volume, conductivity, like that we measure it. Right? Allow to pass that one, then somewhere it decrease and somewhere it start to increase. So you mark those and after then complete the plot. Minimum conductivity that is with the equivalence point, because right, only sodium ions and chloride ions, all OH minus H plus neutralize. තේරුණාද? පැහැදිලිද? Right? So there also we use the conductivity, right, to give idea contribution of H plus OH minus. I explained that one. මේක ඔයගොල්ලන්ට ඉලෙක්ට්‍රොකෙමිස්ට්‍රි වල පොඩියට කියලා දෙනවා, right? මේවෙන් ප්‍රශ්න තියෙනවා පුතේ, පොඩි ප්‍රශ්න තියෙනවා. තේරුණාද? Right? Like that way. Now here OH minus decrease, that one produced, but this one decreased. Because of that one, conductivity decrease. So with the time you can measure that one. With that you can have idea about the rate of the reaction. දැන් හරිනේ? ලියා ගන්න. දැන් පුතේ මේව ඔක්කොම මතක තියෙන ඔයගොල්ලන්ට අද බැලුවොත් එතයි notes ඈ. දැන් මේව මම දෙන්නේ නැහැ උතන්ට. අදම ගෙදර ගිහලා පාඩම් කරන්න ඕන. අනිවාර්යෙන්. Right? ලියා ගන්න. In some of the reactions, ion concentration of the reaction mixture, ion concentration of the reaction mixture change with the time. Ion concentration of the reaction mixture change with the time. Underline ion concentration. Underline change with the time. In such cases, it is possible to measure the conductivity of the solution, instead of concentration. Asterisk mark with a red pen, write this one. In an aqueous solution, In an aqueous solution, H plus ions and OH minus ions, H plus ions and OH minus ions give the highest contribution for the conductivity. Give the highest contribution for the conductivity. Right, that is as a special point, right? Then as a paragraph again, continue this. Consider the following. Consider the following hydrolysis reaction. Consider the following hydrolysis reaction of an ester. Of an ester. Take down this reaction. RC00 R dash aqueous, OH minus aqueous, right? Carboxylic acid anion or minus like that way, aqueous, alcohol aqueous, R dash OH. In above reaction, below this one, right? In above reaction, OH minus ions, in above reaction, OH minus ions in the solution, OH minus ions in the solution highly contribute for the conductivity. Highly contribute for the conductivity. Underline, OH minus ions highly contribute for the conductivity. Therefore, when proceeding the reaction, conductivity of the reaction mixture, when proceeding the reaction, conductivity of the reaction mixture gradually decreases. Gradually decreases with the time. Gradually decreases with the time, comma, because OH minus concentration decrease with the time. Because OH minus concentration decrease with the time. Fourth method, optical rotation. Method. Optical rotation method. දැන් පුතේ මේ kinetics පාඩමේ චූටි කොටසක් මේ how to think about the rate. තව kinetics පටන් ගත්තේ නේ. තේරුණාද? දැන් මෙතන මේ experimental techniques ටික අකු ගන්නන්නේ. දැන් ඉස්සර පරණ සිලබස් එකේ මේවා එකක්වත් උගන්වන්න තිබුණේ නැහැ. මේ අලුතෙන් සිලබස් එක කියන්නේ 19 සිලබස් එකේ තමයි මේ ටික ආවේ. තේරුණාද? එතකොට ඔය විස්තර දීලා තියෙද්දි දැන් අපි ඒගොල්ලන්ගෙන් අහනකොට මේක කොහොමද උගන්වන්නේ? just mention කියලා තමයි කිව්වේ. just mention කිව්වට දැන් මේකේ නාන්තික විතර ලිව්වට හරියන්නේ නැහැ නේ. එහෙනම් පොඩියට විස්තර කරනවා. රිසෝස් එකෙත් ලොකුවට විස්තර කරලා තියෙනවා. තේරුණාද? එතකොට ඒකේ භාවිතය කොච්චරද කියන එක තමයි ඔයගොල්ලන් මේ උගන්වන්නේ. ඉන්න ඒ ටික දැනගන්න right ඒ ඇති ඔයගොල්ලන්ට ඊට වැඩි ඕනේ නැහැ. හරිද? මොකද මේක පොඩි කොටසක්. හැබැයි ඒක ඇතුලේ තියෙනවා දැන් හිතන්නකෝ මේක conductivity using that one they can produce a statement. දැන් ඊයේ පේපර් එකේ හැම අහසක් මුල්ලක් නැහැ අර statements වලට හරවලා තියෙන්නේ. තේරුණාද? MCQ පේපර් එක. එන්න මේව දැනන් ඉන්න ඕන. සීමාවක් සහිතව දැනන් ඉන්න ඕන. right? අතන physical chemistry ගැන ගද්දී අර ඔයගොල්ලන්ට right general knowledge එක තියෙන්න ඕනේ. ඒකයි මම දැන් ඔය උගන්වන ගමන් තැන් තැන් වලට ගිහිල්ලා එක එක දේවල් කියලා දෙන්නේ. දැන් මේ එනකොට ඔයගොල්ලෝ ඉගෙනගෙන තියෙනවා. මොනවාද? H+ OH- contribute give the high contribution for the conductivity. ඒවා අහන් හිටියොත් තමයි සමහර ඒවා ඔලුවට යන්නේ. සමහර ඔක්කොම notes වලට ගන්න බෑ. මම මේ practically වෙනේවනේ explain කරන්නේ. ඒතකොට ඔක්කොම notes වලට දෙන්න බෑනේ. තේරුණාද? එන්න හොඳට අහන් ඉන්න. optical rotation method දැන් මේවා කියලා දෙද්දි පුතේ හරි අමාරුයි කියලා දෙන්න ඔයගොල්ලන්ට. ඇයි? ඔයගොල්ලෝ ගාව දැනුම නැහැ. එන්න පොඩි පොඩි කාරණා විතරක් මම ඉන්ට්‍රොඩියුස් කරලා අවශ්‍ය දේ කියලා දීලා යනවා. right? Now some of the reactions, when you consider some of the reactions, reactants products, optical activity of those reactants and products are different. දැන් ප්‍රශ්නයක් නේ. මොකද්ද? optical activity. ආ ඒක තමයි මම කිව්වේ. ඒගොල්ලෝ just mention කිව්වට අපිට එහෙම කරන්න බෑ. එතකොට දැන් resource එක අරන් කියවුත් ඔයගොල්ලන්ට තියෙන්නේ in some of the reactions optical activity of the reactants and products are different. Therefore in such reactions we can apply this method. තේරුණාද? what is mean by optical activity? පොඩ්ඩක් මම කියලා ඇති කොයිද? optical isomers under that one, right? පොඩ්ඩක් mention කරලා තියෙනවා. කොහමද? Here I will not teach the optical activity completely, but optical isomers under that one I told you this kind of idea. That is, if you take a certain organic compound, related to the organic compound I will tell here, right? Not only for the organic compounds. Organic compounds වල විතරක් නෙමෙයි තියෙන්නේ. හරිද? අපි optical isomers ඉගෙන ගත්තනේ, we learn about that one. Certain compound here, organic compound එකක්ම ගමුකෝ. Compound with a chiral center, asymmetric carbon, මොකක් හරි කමක්. Compound. Into that one we allow to fall the plane polarized light. When passed through this compound, if the plane polarized light, in that one, if the plane of polarization, if it is possible to turn to the clockwise or the anti-clockwise, then we say this compound is an optically active compound. That compound is optically active. Right? In organic lesson you learn such optically active compound can show the optical isomerism. හරිද? The optically active කියන්නේ මොකද්ද? Optically active mean, right, when passing the plane polarized light, plane of the plane polarized light rotate to the clockwise or to the anti-clockwise side. Now to this place, that means the optically active compound can rotate the plane of the plane polarized light. We have a reaction A plus B into C. Optical activity of these and optical activity of these are different. That means this one changed that one clockwise, this one also to the clockwise, this one to the anti-clockwise, like that way. Now when happen in this reaction, what happen? Somewhere it will turn to the left side or the right side, like that way. Optical rotation. So we measure the rotation. That one, how much change there? Say, when forming this one, it changed to the right clockwise direction. How much change? This much. Further change when forming this one. So instead of measuring the concentration of C, what we measure? We measure the optical rotation. Okay, like that way, you can have idea about the rate of the reaction. Tarunad? Liagandi. In some of the reactions, optical activity of products are different from the reactants. Of products are different from the reactants. In such reactions, it is possible to measure the optical rotation. Possible to measure the optical rotation as a function of time. Because optical rotation is proportional to the concentration. Rotation is proportional to the concentration of components in the reaction. Concentration of components in the reaction. Okay, underline. In first sentence, optical activity of products are different from optical activity of reactants. Then optical rotation as a function of time in the next sentence. To measure the optical activity, right? Optical rotation එක mind අපි පාවිච්චි කරනවා, right? We use an instrument, we call that one the polarimeter. Polarimeter. Like that. Okay, next time. The instrument called polarimeter. Polarization, that idea, right? Polarimeter is used to measure the optical rotation. Fifth method. Refractive index method. Refractive index method. Where we can apply that one. When happening some reactions, especially in aqueous phase, when taking place the reaction, right? Refractive index of the reaction medium change. Okay, when performing certain product, refractive index say increase. So with the time, we can measure the refractive index of the whole solution as or instead of measuring concentration like that. Liagan. This method specially used for liquid phase reactions. Specially used for liquid phase reactions. Underline liquid phase. Reactions. Continue that one. Where the refractive index of the reaction mixture changes with the time. Refractive index of the reaction mixture changes with the time. Next method, 6. Number 6, gas evolution method. Gas evolution method. Gas evolution method. Now we can do this kind of thing. Somewhere when taking place a reaction, if one component is a gas, carbon dioxide gas. In the reaction, one component is a gas. What we do, right, with the time, we measure the carbon dioxide volume. Instead of measuring the concentration, what we do? Measure the volume of the carbon dioxide as a function of time. With the time, carbon dioxide volume. At this moment, this much. At this time, this much. At this time, this much. Like that way, volume of the carbon dioxide. Right? Under fixed temperature, pressure conditions like that way, we take the volume. Okay? Then instead of concentration, volume of carbon dioxide, we measure and express the rate using carbon dioxide volume. Right? If there is one gaseous product, if there is one gaseous product in a reaction, then it is possible to measure the volume of that gaseous product. Possible to measure the volume of that gaseous product as a function of time. Example. Take down this reaction. Carbon dioxide gas. Calcium carbonate, calcium oxide, carbon dioxide. In above, volume of carbon dioxide can be monitored. Volume of carbon dioxide can be monitored as a function of time. As a function of time. Right now. Non-disruptive methods, all right. Right. Different types you learn here, right? Have a simple idea about that one. Then, as the next topic, right? Disruptive technique. Disruptive technique. Disruptive technique. Within a bracket, right? Chemical analysis method. Chemical analysis method. Disruptive method. As I told you earlier, right? Here what we do, we have the reaction mixture within time periods, right? 0, 5, 10, 15, like that way. Within time periods, we take samples to the outside. Take samples to the outside, take to the outside, take to the outside, and have to study the concentration of certain components. Say OH minus concentration. I won't determine that one. We do a titration with an acid. By doing a titration with an acid, we can do it. Okay? Like that way, somewhere, take the sample to the outside. After taking the sample to the outside, we do a titration and determine at this time period, this is the concentration of this one. Like that. But as you learned, right, last week, we have problem in this one. Right? Inside this reaction mixture, say E plus B into C reaction happening. After 5 minutes, I take a sample to the outside. And now I am going to do a titration for that one. After 5 minutes, this is the concentration of the component. Like that, I want to determine that one. Problem is, while we are preparing the setup for the titration, reaction still happening, continuously happening. Therefore, difficult to do a titration. By doing a titration, if you determine the concentration, say concentration of this one, actually that is not the concentration in 5 minutes. It is different. Reason is sampling. After taking the sample, even still the reaction proceeding. The concentration of that component change. Because of that one, I told you we do something. What is that? We have to stop the reaction. To stop the reactions, we have different methods in chemistry. Usually we are doing what? At once we lower the temperature of the system. At once we lower the temperature. We call that one the quenching. Quenching. Ekavarama sisil karano. By that what we do? We stop the reaction. Cease the reaction. Stop the reaction. After stopping the reaction, by doing a titration, we can determine the concentration of a component. Okay? Because we stop the reaction like that, we interfere the reaction. That is why we call this one as the disruptive method. Bedana kramaya. Bedana novana kramaya. Bedana kramaya. Disruptive, non-disruptive. Like that. Terunada? Learn. In this method, after mixing the reactants, inside a container, mixing the reactants inside a container, Reaction is allowed to happen. Reaction is allowed to happen continuously. Allowed to happen continuously. Next sentence. But samples are taken to the outside. Samples are taken to the outside with known time periods. With known time periods. And the concentration of a component is determined. Concentration of a component is determined by a titration. By a titration. Next line. After taking a sample to the outside from the reaction mixture. After taking a sample to the outside from the reaction mixture, it is needed to stop the reaction. Needed to stop the reaction before do a chemical analysis. Before do a chemical analysis. Within a bracket, titration. Chemical analysis means titration. Therefore, usually reaction is stopped. Usually reaction is stopped by lowering the temperature. By lowering the temperature within a bracket, quenching. Lowering the temperature, quenching, close bracket, of the mixture immediately after sampling. Mixture immediately after sampling. All right. Right. So the experimental techniques which we can use to determine the rates of reactions. It's over. Two methods, right? Disruptive, non-disruptive, right? Here the disruptive method. Next topic. Factors affecting the rate of a chemical reaction. Factors affecting the rate of a chemical reaction. Right. Now, when you have given reaction, right? Say this one. In the given reaction, stoichiometry of the reaction, 1, 1 react with 3, produce 2, like that way. Stoichiometry of the reaction doesn't give any idea about the rate of this reaction. Okay, stoichiometry not give an idea about the rate of the reaction. If you want to have an idea about the rate of the reaction, then ගේ සති මම ආරම්භ කරේ එහෙමනේ. right? ඔන්න ඔය පොඩි කාරණා තමයි පුතේ හරියටම දැනන් ඉන්න ඕන. නැත්නම් MCQs වරදිනවා. මේ කොහොමද බලන්නකො ඊයේ පේපර් එක වහගෙන කරනවද කොහොමද අහලා තියෙන්නේ කියලා. උතර ඔයගොල්ලන්ට තේරියෝ. right? Stoichiometry not give any idea about the rate of the reaction. Okay? If you want to have idea about the rate of the reaction, what we have to do? We have to study the kinetics of this reaction. චාලකයේ හදාරන්න වෙනවා. To study about the rate of the reaction. Okay? Now, when you consider rate of a reaction, basically, mainly rate of the reaction depend on these factors. One thing is the concentration. Concentration of the reactants. Concentration of the reactants. හොඳින් අහගන්න. right? මේක practical දෙයක්. එහෙනම් හොඳින් අහගන්න ඕන. Concentration of the reactants. When the concentration of the reactants are low, rate of the reaction is low. When the concentration of the reactants are high, rate of the reaction is high. That is why earlier, right, last week when you are learning that one, right, with the time what happened to the rate of the reaction? Gradually decrease. Reactants consuming rate gradually decrease. ගේ පාඩම් වල තියෙනවා කියලා ඉතාලෙන් උගන්වන්නේ. Products forming rate gradually decrease. That is why the gradient gradually decrease. We had a curve there. Gradient decrease. Reason for that one is, right, reactants when consuming, what happened? Concentration of the reactants decrease. Concentration of the reactants decrease mean rate of the reaction decrease. තව පොඩි වෙලාවකින් මම කියලා දෙනවා කොහොමද එහෙම වෙන්නේ කියලා. right? First year I will introduce the factors. After then you have to learn a theory. We call that one the collision theory. සංඝට්ටනවාදය. Collision theory. With that you can have idea how this happening. So concentration I mean rate high, concentration low mean rate low. Usually it happens. But if I give a statement like this way, when concentration of the reactants increase, always rate of the reaction increase. හරිද වැරදිද? ඔන්න අහන විදිය. අර මේ ගණන මෙහෙම අහනවා. That is not correct. Reason for that one later you can learn in some of the reactions, right? Some reactant concentrations not affect the rate. We call them as the zero order reactions like that way. Zero order. ඒක තමයි ඉදිරියේදී හම්බෙන්නේ ඔයගලන්ට. Right? In some of the reactions, some of the reactants concentration of that one not affect the rate. Whether we are using a high concentration or a low concentration, rate is fixed. ඒකට හේතුත් එක්ක පස්සේ ඉගෙන ගන්නවා. හරිද? එහෙනම් if I give you a statement, when concentration of the reactants increasing, always කියලා දැම්මොත් always the rate of the reaction increase, that is wrong. When concentration of reactants increasing, reactant concentrations increasing, usually generally rate of the reaction increase. Yes, that is all right. තේරුණාද? පිළිතුරු ගන්න පිළිවෙල. Right? Concentration is one factor. In some cases, it is difficult to measure the concentration. Nitrogen, hydrogen, ammonia, all are gases. What we do? Instead of measuring concentration, we measure the pressure, partial pressures. Because PV equal nRT, P proportional C. Then තර්ක තියෙන්නේ, right? Concentration, right? Increase mean pressure increase. So they are proportional because of that one. Instead of concentration, if gas phase reactions, gaseous reactants, instead of concentration, we measure pressure. Pressure effect. Pressure effect to the rate of the reaction. තේරුණාද? ඒව වෙනම explain කරනවා එතකම්. Second one is temperature. Second one is temperature. When you consider the rate of a reaction, temperature directly affects the rate. Temperature directly affect. Usually in a reaction, when temperature increase by small amount, rate of that reaction considerably increase. When temperature increasing, rate considerably increase in the reactions. Okay. Now, if I give you a statement again, when temperature increasing, rate of any chemical reaction increases. Rate of all reactions increase. No, that is not correct. ඉස්සර හරි. දැන් වැරදි. 2019 පස්සේ වැරදි. එතන පරණ බහුවර්ණවල කයිනෙටික්ස් වල උත්තර තෝරද්දි තනද ඔයගොල්ලන්ගේ ආන්සර්ස් වල දින මාකින්ස් වල තියෙන උත්තරම හරියන්නේ නැහැ. ඒවා වෙනස් දැන්. 2019ට කලින් ඒවා 2011ට කලින් ඒවා ඊටත් වඩා වෙනස්. හරිද? එතකොට ඒවට අපි උත්තර ගන්න ඕන. දැන් අපේ සිලබස් එකේ පිළිවෙලටයි උත්තර ගන්න ඕන. Reason for that one is මම කලින් කිව්වා ගිය සතියේ මොකද්ද? Some of the reactions are very fast. කිව්වේ නැද්ද? කිව්වා. Instantaneous reactions, very fast reactions. Right? Because some of the reactions are very fast, you increase the temperature with that. Now, say 10 to the power minus 12 second, that much of fraction of second with that one, right? Reaction passes the completion. I increase the temperature with that. This one 10 to the power minus 12, now it passes 10 to the power minus 13 of a second. Not a considerable change. Not a considerable change. Because of that one, ඇත්තටම ගත්තොත් චූටි හරි වෙනසක් වෙනවා. මේකෙත් එහෙම. concentration එකෙත්. එතකොට ඇත්ත සහ උත්තරය. හරිද? concentration එකෙත් එහෙමයි. They are also actually when concentration increase, right? In all reactions, rate increase. But in some of the reactions, it is not a considerable change. මං කිව්වේ අර 0 ඩ කියලා. ඒ වගේදී considerable change එකක් නෙමෙයි ඒක. එහෙනම් අපි ගන්නවා මොකද්ද? In all reactions, it won't happen. Like that here also, when temperature increasing, in all reactions, rate not increase. Right? In most of the reactions, considerably increase. හරියටම පාඩම් කරන්න ඕනේ. මම විස්තර කරලා දෙනවා දැනට. Concentration, temperature. Third factor is the physical nature of the reactants. Physical nature of the reactants. Right? Sometimes we can use the powder. Sometimes we can use the lump of the sample. Calcium carbonate, a lump of calcium carbonate. Calcium carbonate powder. Like that. The nature of the particles with that. Right? In another way, physical nature mean, right, whether it is solid, liquid or gas. Now, when you consider gas phase reactions, they take place rapidly. Then solid or liquid. Solid phase reactions take place slowly. Reason? In solid phase reactions, only the surfaces. Right? Another reactant possible to contact with the surface only. Inside particles with that one. No way to contact. But in liquid phase, possible to contact. In gaseous phase, from everywhere, it is possible to contact. Like that. So, physical nature and the surface area. If I break this one into two parts, another surface open. If I break that one like this way, another surface open. More surfaces. Same mass. If I take the bulk of that one or the powder of that one. Powder mean more surface area open. More surface area open mean more possibility to contact the other particles. Right? With that rate change. Next factor is that one. Physical nature and the surface area. Okay. Then the fourth one is the catalyst. Catalyst. When you add the catalyst, right, what happened? Catalyst gives support to the reaction. Catalyst always increase the rates of any chemical reaction. Catalyst always increase the rate of reactions. Right? Then parana kale uttara toraddi, komada uttara torani. Catalyst change the rate of a reaction. Increase or decrease. Change. 2011 කරින් උත්තර තීරුවේ එහෙමයි. උත්ප්‍රේරකයක් ප්‍රතික්‍රියාවක වේගය වෙනස් කරයි. වැඩි කරයි නෙමෙයි වෙනස් කරයි. Now always increase the rate of a reaction. Catalyst increase, retarders decrease. Like that way. තේරුණාද? Like that way, mainly we have to consider these four factors that affect the rate of a reaction. Mainly these four in our syllabus, right? Our lesson in that one, we study about these four. Mainly these four. Except that one, some other factors possible to affect the rates of reactions. For example, right, when doing the reaction, right, the reactants, where that reactants, where we dissolve that reactants, solvent. We dissolve the reactants in water and allow to happen the reaction. Same reactants we dissolve in methanol medium instead of water. Then the rate of the reaction is different. Because the movements of the particles differ in different solvents. In different solvents, the movements of the particles different. Because of that one, rate of the reaction change. Then api electrochemistry wala samarala electroplating karadin. Doing the electroplating, right? When we want to, right, do the reaction slowly. For that one, we increase the viscosity of the solution. Solution ke viscosity ke වැඩි කරනවා. දුෂ්‍රාවිතාව. Right? For that one, we add small amount of agar and jellified medium. එතන මොකද වෙන්නේ? දැන් ions වේගෙන් යන්නේ හැමින් යන්නේ. Conductivity of the ions decrease, slowly moving. Then the process happens slowly. Like that. The reaction rate, right, also depend on the solvent. Okay, like that is some other factors even possible. But basically, these four factors, and we want to study about that one with lot of details. මේ ටික details එක ඉගෙන ගන්න ඕන. හරිද? මොකොත් ගැටලු තියෙනවද නොතේරෙන තැනක්? නෑනේ. එන ලියා ගන්නකො. හොඳට අහගන්න හොඳට පාඩම් කරන්න. හරිද? නීට් එක තමයි ඕන. මේක අර ජෑම් කරගන්න එපා. ඉගෙන ගන්න එක මම ඔයගලන්ට නීට් එකට නෝට් එක දෙන්නේ. පිළිවෙලට ඒ දෙන පිළිවෙලට ඔයගොල්ලෝ ස්ටඩි කරන්න තව ඔයගලන් ඉවර නෑ. ඔක්කොම කාරණා කියලා දෙන්නම්. හැබැයි ඒ නීට් එකටම ඔළුවේ තියාගන්න. ඒකට තමයි උත්තර වලට යන්න ලීසි. නැත්තම් බැරින උත්තර එක්ක වැඩි කරන්න අමාරුයි. ගිය අවුරුද්දේ මොකද MCQ පේපර් එකකින් එක ගොඩක් තහවුරු වුණා. මේ අවුරුදු පේපර් එකත් ඒහා සමානවම ගිහිලා තියෙනවා. තේරුණාද? තියරි තමයි තියෙන්නේ ඔක්කොම. right? ගොඩ ලස්සනට අහලා තියෙනවා. හැබැයි ඉතින් මාස් පේපර්ස් ටික කරපු අයට ඒ වගේම පේපර් එකක්. තේරුණාද? ඒහා සමානම පේපර් එකක් තියෙනවා. අමාරු නෑ. හැබැයි හරියට පරිස්සමෙන් උත්තර තෝරන්න ඕන. තේරුණාද? දැන් ඕගනික් කම්පවුන්ඩ් එකක් දීලා තියෙනවා. අර මං කිව්වේ ඔයගොල්ලන් සාමාන්‍යයෙන් 3 වෙනි 4 වෙනි ප්‍රශ්නේ කියලා බහුව අරන. තේරුණාද? ඒකේ දැන් ඔයගොල්ලන්ට කියලා දුන්නේ අර functional group. දැන් මේ ඊයේ තියෙන එකේ right functional group OH is there. Then NH2 group and halogen. Halogen is indeed from both sides same number to the OH. OH එකම number එක. තේරුණාද? From one side halogen is the number 1. 1 2 3 halogen with that one. From the other side second carbon NH2 1 2 3. තර කොහෙන්ද නම්බර් කරන්න ඕන කියලා බලලා උත්තරය ගන්න තියෙනවා. halogen එක තියෙන්නේ පළවෙනි කාබන් එකේ NH2 තියෙන්නේ දෙවෙනි කාබන් එකේ. එක පැත්තකින් තියෙනවා NH2 group is the substituent, then third carbon, fourth carbon is the OH. අනිත් පැත්තෙනොත් fourth carbon is with the OH. But halogen is with the first carbon. එහෙනම් කොහෙන්ද? halogen ගේ පැත්තෙන්. එයාට number 1නේ. substituent group එකට අඩුම අංකය. like that way. හරිද? ලියා ගන්නකො එනම් මේක. Factors affecting the rate of a chemical reaction. On that one. A balanced chemical equation. A balanced chemical equation gives the quantitative relationship in between the reactants and the products. In between the reactants and the products. Come on. But it doesn't but it doesn't give any idea. It doesn't give any idea about the rate of the reaction. Any idea about the rate of the reaction? Next line. It is possible to have an idea about the rate of the reaction only by studying the chemical kinetics of the reaction. Studying the chemical kinetics of the reaction. Next line. Rate of a chemical reaction. Rate of a chemical reaction depend on number of factors. Rate of a chemical reaction depend on number of factors or various factors. Number 1, reactant concentration. Number 1, reactant concentration. Within a bracket, pressures if gas. Pressures if gases. Pressures if gases. Reactant concentrations within a bracket, pressures if gases. Reactant concentrations, pressures if gases. Number 2, temperature. Number 3, physical nature within a bracket, solid, liquid, gas, aqueous. Physical nature and surface area. Number 4, catalyst. Below that one. Except above factors, except above main factors, correct, like that. Except above main factors, except above main factors, some other factors, even sometimes, some other factors even sometimes affect to the rates of reactions. Effect to the rates of reactions. Example. Sometimes solvent that used to dissolve the reactants, solvent that used to dissolve the reactants can also affect to the rate of the reaction. Can also affect to the rate of the reaction. Harida, next topic. Use of collision theory. Use of collision theory. Within a bracket, molecular kinetic theory. Use of collision theory within a bracket, molecular kinetic theory, close bracket, to explain the effect of various factors, to explain the effect of various factors. Livine, I can now. In the use of collision theory within a bracket, molecular kinetic theory. Then what monkey ආගෙන ලියන්න. මට බලන්නකෝ තායත් ලියවෙන්නේ. Collision theory within a bracket, molecular kinetic theory, to explain the effect of various factors to the rate of a reaction. To explain the effect of various factors to the rate of a reaction. Rate of a reaction. Under that one as a subtopic, right? Collision theory. Collision theory. Then අහගන්න. Now, when you consider, right, the chemical reaction, reactants are there. Maybe solid, liquid, or gas like that way. Now here, especially we consider liquid phase, gas phase. Solids for that one also, we can consider this one. So collision theory mainly for the liquids and gases. Reactants. Say two different types of reactants. This mean one type, this mean a different type, two reactants. In all in a reaction mixture. According to this collision theory, we believe the particles are moving here and there. The moving particles, they have to contact one another. They have to collide one another to start the reaction. Say for example, right? Say hydrogen and oxygen, for example, mix in that container. Want to produce water mean want to produce OH bonds, no? H2O have to have the OH bonds formation to produce the water, another OH here, like that way. So to happen that one, hydrogen and oxygen molecules, they have to colloid one another. ඒගොල්ලෝ එකිනෙක නා හැප්පෙන්න ඕන. Then when taking place the collision, some of the bonds break and some of the bonds newly produce. With that pass into the product. Okay. Now, like that way, when you have mixture, reactant mixture, right, the collisions taking place. Some of the collisions, right, taken place there, right, they collide one another, but after that one, they bounce back. They bounce back without passing into a product. Some of the collisions, right, taken place and they pass into the product. Okay. So most of the collisions taken place actually not pass into the products. Actually not pass into the products. But, right, some of the collisions can pass into the products. Somewhere if taken place a collision and if the reactant, collision of that reactants pass into the products, then we can say that collision as an effective collision. Sapala sangattanayak. We call that one as an effective collision. So to take place an effective collision, right, the colliding particles or the molecules should fulfill, right, should complete some requirements. Just a collision, not pass to the product. Right? If that molecules complete some conditions, then it is possible to pass that one into a product. So in this collision theory, we will learn about that one. Collision theory explain that one. How the reactants pass into the products. First write this introduction. In a chemical reaction, collision theory under that one, in a chemical reaction, reactants are passed into the products. Reactants are passed into the products. Full stop. To happen this, full stop and write. To happen this, reactant molecules, to happen this, reactant molecules must involved in, reactant molecules must involved in collisions. Must involved in collisions. Full stop. When reactants are introduced, when reactants are introduced into a container, comma, reactant molecules randomly move inside the container. Move inside the container, comma, can involve in collisions. Can involve in collisions. Can involve in collisions, comma, but most of these collisions will not pass into a product. Will not pass into a product. Next line. Leave one line and write this. Rula Kerala. A collision taken place. A collision taken place in between reactant molecules. Taken place in between reactant molecules. Come on. If proceed towards the products. If proceeds towards the products. Proceeds towards the products. Then it is said to be an effective collision. Said to be an effective collision. Effective collision. Next line. Online karagane effective collision. Next line. Reactant molecules should fulfill certain conditions. Reactant molecules should fulfill certain conditions to have an effective collision. To have an effective collision. What are the conditions? First requirement is the molecule should come close and have to collide. Come into contact. Without contacting the reactant molecules, no way to have a product. They must come and collide one another. First requirement is that one. Then, like that way, actually, a lot of collisions possible. Lot of collisions, they are not successful. They will not pass into the products. Not effective collisions. A collision, they come into contact. A collision possible, but to become a collision, an effective collision, another two requirements have to fulfill there. One thing is the colliding particles, colliding molecules. They should be with enough energy, right? There we say, right, they should be with certain, they should be with certain minimum energy or energy more than that one. That minimum energy, we call that one is the activation energy. Right? Right? The colliding molecule should be with certain minimum energy. Or more than that one. Minimum energy, we call that one the activation energy. What is mean by activation energy? Later I will explain it. Tell that. Now they are with enough energies. With that enough energies, collision taken place. With that, even not possible to pass into a product. They should be with enough energy. Actually, right, when coming the particles like this way, right, when they are coming like this way, say for example, hydrogen and iodine in gas phase, hydrogen and iodine molecules coming closer. Electron cloud here, electron cloud here. In hydrogen molecule, electron cloud here, electron cloud. When they are coming closer, what happens? Electrons, negative, they have repulsions. Now they are coming here, mean they are with the kinetic energies. When closing, kinetic energy decrease, they become slow. Kinetic energy decrease and that energy stored as the potential energy when they are coming closer. If they are with enough energies, the electron clouds are possible to overlap properly. If they are with enough kinetic energies, right, electron clouds can overlap properly. Properly, I mean, in some cases, they are not with enough energies. The electron clouds overlap, but not a proper overlapping. Because of that one, After colliding even, again they bounce back. When they are coming closer, they decrease their kinetic energy, store the energy as potential energy. Right? Somewhere, if the collision is successful. In some cases, no enough energy there, it is not successful, again bounce back. Again, potential energy into kinetic energy and remove. Bounce back. Should be with certain minimum energy, we call that one as the activation energy. In some cases, activation energy is there, enough energy is there, but not take place the collision with a proper orientation. Okay, with a proper orientation. For example, now if I consider this one, if I consider NO, right? First I will write the reaction. NO plus Cl2. Give NOCl. Give NOCl. When taking place this collision, right? Say the NO molecule is like this, see? Cl2 molecule is like this way. Forming NOCl is like this way. NOCl means this kind of one. Now, requirement is how to produce a bond between nitrogen and chlorine. How to produce a bond between nitrogen and chlorine. Now, if a collision taken place like this way, oxygen and chlorine if collide one another, whether bond possible between nitrogen and chlorine? No. May then happen. With that nitrogen chlorine bond possible? No. So that is not a proper orientation, not a suitable orientation. All right. Therefore, if it happen like this way, now it is possible, right, to produce a bond between nitrogen and chlorine. Though the orientation is all right like this way, if they are not with the enough energy, then again no way to produce a bond. That is why I told you, right? Sometimes thousands of collisions, anyone not passing to the product. In gas phase reactions, right, in some cases, not thousands, right? Lot of collisions possible, more than that one, but no product formation. Rarely a product formation possible. Condition is should be with the proper orientation, as well as these colliding molecules should be with enough energies to produce that overlapping properly. Right? A proper overlapping to take place, that one there must be, right, enough energy there. So suitable orientation and enough energy. If both fulfill, then a possibility, then always pass to the product. We can't say මට මේ වචනේ ඕන ඔයගොල්ලන්ගේ උත්තරවලට, right? Always they are also all pass to the product. No. Possibility to give a product. Then it is an effective collision. ඒක සඵල සංඝට්ටනයක්. Okay? තේරුණාද? කෙටියෙන්. තව තියෙනවා විස්තර, right? So first thing is the molecule should come into contact. Then colliding molecule should be with certain minimum energy or more than that one. Then they should be the proper orientation. Later, now still you are learning here, no? Still you are learning here. Later, right, when they are asking, then there should be certain minimum energy or more than that one. We call that one the activation energy. Later, when they are asking, what are the factors how to fulfill? Directly you can give. Molecules should collide one another. First thing, the colliding molecules should be with activation energy or more than that one. එතකොට අපි activation energy explain කරන්න යන්නේ there must be certain minimum energy or more than that one. දැනට මේ කියන්නේ. ඔගොල්ලෝ තාම දන්නේ නැති හින්දා. Later, when you are writing the answer, directly you can say they should be with the activation energy or more than that one. The particle should collide with the proper orientation. Okay, those are the conditions. Now the same question, if they ask by giving this one and this one. Reaction given like this way, what are the conditions have to fulfill to give the product? දැන් ඔයගොල්ලෝ කටපාඩම් කරගෙන ලිව්වට හරියන්නේ. The particles must come into contact. They should be the proper orientation. They should be with the energy more than the activation energy. එක ලකුණක්වත් නැහැ. ඔන්න ඔක තමයි ප්‍රශ්නේ. ඇයි නැත්තේ? They have specifically given a reaction. Therefore, relate to the reaction, you have to give the answer. තේරුණාද? කොහොමද නම් උත්තරේ ලියන්නේ? කොහොම ලියපුවාමත් දැන් කලින් කිව්ව විදිහට ලියපුවාමත් ලකුණු දුන්නා ඉස්සර. දැන් දෙන්නේ. තේරුණාද? දැන් ඔයගොල්ලන්ගේ lessons පොතේ ටික තීව්‍ර කරලා තියෙන්නේ. තේරුණාද? සමහර contents අයින් කරලා තියෙනවා, සරල කරලා තියෙනවා. හැබැයි උත්තරය neat වෙන්න ඕන. ඒ terms හරියට නැත්තම් ලකුණු නෑ. මාකින් හදද්දි මාකින් කී මෙහෙම කියලා අන්ඩර්ලයින් උත් කරලා තියෙන්නේ. මේ term එක තිබුණොත් දෙන්න ලකුණු. ඒ කියන්නේ specifically you have to learn it. මේකට answer එක දෙන්නේ කොහොමද? NO and Cl2 molecules should come into contact. Then මෙයාගේ ලියන්න ඕන. Right? Then the NO and Cl2 molecule should be with the energy more than the activation energy. Orientation කොහොමද ලියන්නේ? Orientation particles should collide with the proper orientation කිව්වට හරියන්නේ නැහැ. Nitrogen atom of the NO should collide with the chlorine atom of the Cl2 molecule. On the proper orientation. තේරුණාද? Commonly if they ask that one, we say they should be the proper orientation. But if they have given a reaction and ask how to say this atom of this molecule should collide with this atom of this molecule, then it is possible to give a product. Adili, Leo, right? ඔය දැන් කෙටියෙන් කියලා දුන්නේ ඊළඟට with details. ආයෙත් ඉගෙන ගන්න තියෙනවා. මේකට මම examples දෙනවා. Number one. Molecules must come into contact. Molecules must come into contact. Leading to a collision. Come into contact, leading to a collision. Leading to a collision. Number two. Reactant molecules must collide in a proper orientation. Reactant molecules must collide in a proper orientation. Which allows the necessary bond breaking. And bond forming. Bond breaking and bond forming. To transform the reactants. Into products. To transform the reactants into products. Within a bracket, right? Within a bracket. Reactant molecules should colloid with a proper orientation. Should colloid with a proper orientation. Close bracket. Right? Now, within a bracket given the term, that is, if they ask what are the conditions like that, later when you are writing that one, they should be with the proper orientation. කෙටි කරලා ලියන්න පුළුවන්. Colloid particles should be with the proper orientation. ඒක ටිකක් පැහැදිලි කරලා තමයි අර උඩින් ලිව්වේ අපි. Necessary bond breaking, bond forming, like that. Third point. Reactant molecules must, third point, reactant molecules must colloid with enough energy to overcome an energy barrier full stop. This minimum energy required is called the activation energy, activation energy for that one with the capital E, activation subscript simply activation energy of the reaction right, certain energy barrier, how to overcome that one adu ganna no, right, within a bracket, right. දැන් මේ විස්තරේ මොකල්ලෝ උත්තරයක ලියද්දි කොහොමද කෙටි කරන්නේ? එතකොට ආය අපිට activation energy explain කරන්න ඕනේ නැහැ. ඔයගොල්ලෝ කෙලින්ම කියන මොකද්ද? The colloiding molecule should be with the activation energy or energy more than that. Okay? Within a bracket, right? Colloiding reactant molecules must be with the activation energy colloiding reactant molecules must be with the activation energy or energy more than that. Must be with the activation energy or energy more than that. What topic aliyana subtopic collision frequency. Collision frequency. What is mean by collision frequency? Right? When you consider a system, right? In this system, number of collisions take place per unit volume, per unit time. Number of collisions taken place per unit volume, per unit time. ඒකක පරිමාවක ඒකක කාලයකදී සිදුවන ගැටුම්. If I say collision rate, then I give collision frequency. Collision rate, number of collisions taken place per unit time. ඒකක කාලයකදී සිදුවන ගැටුම් සංඛ්‍යාව. රේට් එක. ෆ්‍රීකවන්සි එනකොට වොලියුම් එකෙනුත් බෙදුවා. per unit volume. හරිද? දැන් මම example එකක් කියන්නම්. When you are increasing the reactant concentration, rate of the reaction increase. තා පොඩ්ඩකින් explain කරනවා. How it happens? You are increasing the concentration. මේ terms මෙහෙම වුණ පුතේ. ඒ කියන්නේ definitions මේ. Increasing concentration mean what you do? Increasing concentration, right? Increase the number of molecules කිව්වොත් උත්තරේට ලකුණු නැහැ. Increasing concentration mean increase the number of reactant molecules per unit volume. ඝන decimeterයට මවුල. Number of moles per cubic decimeter. In unit volume, the number of particles increase. එකයි මං කිව්වේ. ඔයා දැන් ඉස්සර සරලව ලියුවාම ලකුණු දෙනවා. දැන් හරියටම ලියුන්නේ නැත්නම් ලකුණු නැහැ. Increasing concentration increase the number of molecules, reactant molecules per unit volume. With that, what happened? Number of collisions per unit volume per unit time increase. Number of collisions per unit volume per unit time increase. Meaning in another way, collision frequency increase. How is it? Collision rate per unit volume increase. Kalpanaving. Collision rate, number of collisions per unit time. ඒ දෙක එකතු කරලා මම කියවා collision rate. Collision rate per unit volume increase. ඒක මම පරිමාවෙන් බෙදුවා. හරිද? දැන් ඔය මං කිව්වේ අර සංයමයේ තමයි ඕනේ. මං කිව්වේ කල්පනාවෙන් ඉන්න ඕන. හිස් ඔලුවක් අරගෙන පන්තියේ වාඩි වෙන්න කියලා. ඒ කල්පනාව තියෙනවා නම් ඔයගොල්ලන්ට මේ ඔරුවට එනවා. හරියටම ගන්න ඕනේ. තේරුණාද? Right? Concentration increase with that thing happen. With that you can explain how the rate increase. අපි බලමු ඊළඟ කොහොමද ලියන්නේ කියලා. පැහැදිලි? Like that way the frequency mean per unit volume, per unit time, right? How much of collisions? ලියමු අපි. පොඩි definition එකක් මේ දැන් ඊළඟට explain කරන්න යන දෙයට මට ඕන වෙනවා මේක. එහෙනම් මම definition එක දීලා ඉන්නවා. Right? Number of collisions taken place. Number of collisions taken place per unit time within a bracket, right, per second, within a bracket per second, close bracket, per unit volume of the reaction mixture, per unit volume of the reaction mixture. තව ටොපික් එකක් ලියන්න collision rate කියලා. Collision rate. Number of collisions taken place per unit time. Number of collisions taken place per unit time. Unit time. On bracket එක ලියන්න per second. Per second. Close bracket. Leave one line. Rule අක්කරින්ද. දැන් අර theory ඇතුලේ මම මේ definition එකක් දුන්නේ ඈ. ආපහු යනවා අපි විස්තරයට. Ruler Kalaliana. Collision theory explains. Collision theory explains that how the rate of a chemical reaction explains that how the rate of a chemical reaction depend on rate of a chemical reaction depend on the number of collisions per unit time per unit volume. Per unit time per unit volume. Right? As told earlier. Now, usually when you consider the reactions involved in solid phase, right? Then මේ කියලා දෙනවා පොඩි statement කරනවා. Right? Reactants involved in solid phase are slow and the reactions involved in liquid and gaseous phases are usually high. Rates of those reactions high. කියලා කිව්වොත් ඔව්ද නැද්ද? ඔව්ද? දැන් collision theory එක ටිකක් දන්නවනේ. තව ටිකක් කියලා දෙන්න තියෙනවා. Right? Solid phase reactions generally they are slow reactions. Why? Limited number of collisions because only the phases මොහොනත් ටික විතරයි. Right? Only the phases possible to contact with the other. Therefore, solid phase reactions they are slow reactions. Compared to that one, liquid phase, aqueous phase, gaseous phase reactions, right? In liquid phase, even now the particles move one over the other one like that way in the liquid phase. In aqueous phase, also like that way, but movements possible because of that one, right? With that, rates of the reaction somewhat high. Gaseous phase in that one, randomly moving particles everywhere collisions possible. Okay. Therefore, compared with the solid phase, liquid phase and gaseous phase reactions, they are with high rates. High rates. තේරුණාද? දැන් ගිය සතිය මම ඉගෙනුවා මෙහෙම. Instantaneous reactions. දැන් statement එකක් හදනවා නම් අපි. මොකද්ද? Usually the reactions involved in or the ionic species, reactions involving ionic species, they are instantaneous reactions. හරිද? Ionic species involved in reactions ගත්තොත් ඒවා right, they are very fast reactions. Yes. එම නේද? ආන්න ඒ වගේ. අපි නොහිතනා විදිහට තමයි ඒගොල්ලෝ වගන්තිය හදාගන්නේ. අපි මේ ඉගෙන ගත්තු කාරණා. තේරුණාද? ඒවා ඔයගොල්ලෝ තහවුරු කරගෙන තියෙනවා. ලියමුකෝ. astic mark එකක් දාලා යන්න. Usually reactions take place in solid phase. Usually reactions take place in solid phase. Take place in solid phase. Solid phase online are very slow. Are very slow. Come on. Are very slow. Come on. Because only the atoms in surface, only the atoms in surface can colloid can colloid with atoms of other reactant molecules. With atoms of other reactant molecules. Examples. Rusting of iron. නම විතරක් ලියන්න ඇති. Rusting of iron. So rusting of iron, in that one only in the surface reaction taken place. So it's a slow process, right? Next line. Most of the reactions taken place in solution. Or in gas phase. Underline solution or in gas phase. Are with randomly moving particles. Randomly moving particles. Comma. Allow them to easily come into contact. And thereby allow them to easily come into contact. And thereby more collisions per unit time per unit volume. More collisions per unit time per unit volume. Is possible. Per unit time per unit volume is possible. Within a bracket, right? Within a bracket. Collision frequency is high. Collision frequency is high. Collision frequency is high. Close bracket. They have rates of reactions in liquid phase or in gaseous phase. Rates of reactions in liquid phase or gas phase are usually high. Underline current last sentence. Next topic. Collision orientation. Collision orientation. Okay, take the note. කියලා දීලා තියෙන්නේ examples ගමු අපි. තාටිය වෙලා කියලා විවේක දෙන්න. තාම පැය දෙකයි නීතිය. 8ටනේ පටන් ගත්තේ පන්ති. දැන් 10යි. 10 මාට ගමු බ්‍රේක් එක. නැත්තම් එක වෙනකන් ඉන්න අමාරුයි. නේද? එතකොට ආයෙත් බ්‍රේක් එකක් කියලා. එතකොට බ්‍රේක් විතරයි අද. එහෙනම් තව පොඩ්ඩක් කොහොම යන්න. මේ වැඩි ඉවර කරන්න බෑ පුතේ. නිවාඩු කාලේ කොහොම හරි මේ වැඩි ඉවර කරගන්න ඕනේ. පොඩි ජයග්‍රහණයක් ලබන්න නම් මේක ප්‍රයෝජනවත් වෙන්න ඉපේ. නේද? දැන් පන්තිය මම ඇත්තටම 2 3 විතර වෙනකම් කරන්න හිටියේ. මැද්දේ ලොකු බ්‍රේක් එකක් දීලා එහෙම හිටියේ. දැන් අර හවස පන්තියක් එදිච්ච හින්දා මට නෙමෙයි ඕගොල්ලන්ට. රයිට්. වාදාවක් තියෙන ඉඳ මම එකට නවත්තන්න. 12:45 විතර නවත්තනවා. හරි? ඒ ඉඳ පොඩ්ඩක් ඉවසගෙන ඉන්න. රයිට්. ඒ අතරේ දැන් කාට හරි වොෂ්රූම් එකේ යන්න ඕන නම් ගිහිල්ලා ඉන්න ගැටලුවක් නැහැ. රයිට්. ඕකනේ ගැටලුව ආවොත් දැන් ඉන්න පුළුවන්. ඒක ඉතින් ස්වභාවික ගැටලුවක් නේ. ඉතින් ඕන්න යන්න කොනේ ලේක. ගැටලුවක් නැහැ. රයිට්. ලියන්න නෝට් එක. When taking place a reaction, when taking place a reaction, comma, reactant molecules should collide